Welcome to our lesson on solving quadratic equations by factoring. In this lesson, we will solve quadratic equations by factoring, and we will also be writing quadratic equations in standard form starting from their roots or solutions. So we're going to work backwards as well. So let's jump right in. To solve by factoring, we will be using the zero product property, and basically the zero product property says that if you have two real numbers that are multiplied together, and you end up getting 0, then one or both of those factors must be equal to 0. Now remember, a factor is something that's multiplied by something else. So A and B here are factors. So here's an example. Let's jump right in, and we want to solve by factoring. So the first thing we need to do is put this equation in standard form. So we're going to subtract 6x from both sides. So in standard form, this is what it looks like. Notice we don't have a c term, it's just equal to 0. And so it's in standard form, but now we need to write it in factored form, where it's a product of two numbers. So the only thing that I can do with this one is they both have a factor of x. So I'm going to take out the greatest common factor, which is x, and I'm left with x minus 6. So now it's in factored form. We have two things that are multiplied together that are equal to 0. So you might think of this as a being x and b being x minus 6. So the next step is, once we have it in fully factored form, is to set each factor equal to 0 and solve. So I'm going to set this factor equal to 0 and this one equal to 0. Well, the one on the left, x equals 0, is already solved. When we set this one equal to 0 and solve it, we add 6 to both sides and we get x equals 6. So now we have our solutions are x equals 0 and x equals 6. The last thing we need to do with this is to go ahead and graph it, and the way we want to graph it is to find the vertex. And you'll recall that the vertex is negative b over 2a. Well, in this example, b was negative 6, and then a was 2. So we end up getting the vertex. First of all, the x-coordinate of the vertex is 3. If we plug that back into our original equation, 3 squared minus 6 times 3, we end up getting negative 9. 9 minus 18 is negative 9, so our vertex is the point 3, negative 9. And from the last slide, we found out that the x-intercepts, those solutions, were 0, 0, and 0, 6. It crossed at y equals 0 and y equals 6. Excuse me, x equals 0 and x equals 6 on the x-axis. And so we want to go ahead and graph those, and I think I have those in here. This one's in here backwards. This is the point 6, comma 0, right? It's an x-intercept, not a y-intercept. So make that correction for me. So on our graph, we're going to graph those points. Here's 0, 0, here's 6, 0, and here's 3, negative 9. We have our axis of symmetry, so then we can sketch in the curve just with using those 3 points. Here's another example, and we want to solve it by factoring. So the first thing we need to do is put it in standard form, which it already is in standard form. We need to factor this trinomial, so we want factors of 64 that add to 16. Signs are the same and they're both minus. So if you need to review your factoring, there's a little note for you down here. Scan that QR code and it'll send you to a site where you can practice that. So 8 and 8, when you multiply, you get 64, and when you add them, you get 16, and they're both negative. Our zero product property says if you have two things that are multiplied equal to 0, either one or both of them is equal to 0, so you set them equal to 0, and you get x equals 8 for both solutions. So we only have one number in our solution set, and that's 8. And you may recall from our last video, we may get two solutions, we may get one solution, or we may get no solution. This is an example where we only get one solution. So if we want to work backwards and write a quadratic equation in standard form, starting with the roots, what we need to do is write the roots as factors and then use FOIL. Okay, so if I have these two factors, here's an example. I have the root negative 1/3 and positive 4. What I'm going to do is I'm going to say, okay, x equals negative 1/3 and x equals 4. And now try to write it as a factor. So you want to get the 1/3 with the x. So we're going to multiply both sides by 3. So I get 3x equals negative 1. And we want to get a 0 on this side. Okay, so then what I'm going to do is add 1. and I end up with 3x plus 1 equals 0. This is now a factor, 3x plus 1. I could have just added 1/3, but if we use this form, we won't have to multiply to get our equation back in standard form. I can explain that further in class if you don't understand that. This one we just subtract 4 from both sides, and x minus 4 is a factor. So we have our two factors, 3x plus 1 and x minus 4. So now we're going to multiply those. So we have an a and a b, and we're going to multiply the a times the b together. Well, this is where we use FOIL. So our first terms give us 3x squared, our outside is minus 12x, inside plus x, and last is minus 4. And combining our outer and inner term, we get 3x squared minus 11x minus 4 is equal to 0. This is now in standard form. If we had used the factor x plus 1/3, we would have a fraction in here, and we would have to multiply by the denominator. And so it just takes one step out if we use the factor without the fraction over here. So I've left one for you to try on this page. Write a quadratic equation with -5 and positive 1/2 as its roots, and write it in standard form. You're going to follow this process almost exactly. You just have two different roots. So try that on your own and bring your answer to class.